Primitive function. Basically, it's going back the other way. It's called the primitive function because it's like saying, where did we start? So if we know the equation of the tangent, how do we find the original curve? So where did it come from, this equation of the tangent? We start by looking at polynomials because they're the easiest ones to do. If we know the derivative, because we've got the equation of the tangent, so we've worked out what the derivative is, and we know that's x to the power of n, well, how did we get there? Well, when we differentiated, we subtracted 1 from the power. So therefore, to go back, we should add 1 to the power. And when we differentiated, we multiplied by the original power. So therefore, this time we should divide by the original power, but the original power would be n plus 1, not n. So hence we get x to the power of n plus 1 divided by n plus 1. But we also have to add a constant, because the other thing we know is when we differentiate a constant, we get 0. So if we're going back the other way, how do we know there wasn't a constant number there? So we've got to take that into account as well. So something like this, we've got 3x to the power of 4. Where did it come from? Basically, add 1 to the power over that power. So add 1, we get 5. So we get 3x to the power of 5 over that power, 5, plus some constant number. Just like when we're differentiating, when we go back the other way, we just do it a term at a time. So the 6x cubed, add 1 to the power, we get power of 4 over 4. 5x squared, add 1 to the power, we get 3 over 3. X, well that's x to the power of 1. So add 1 to the power, we get 2 over 2. That constant number 2, well remember that's really 2x to the power of 0. Add 1 to the power, we get power of 1, so we have x. Plus, of course, a constant. But we can tidy some of that up. 6 over 4 is the same as 3 over 2. Now, whether you write the pronumeral in the numerator or you prefer to write it as the fraction times the piece of algebra, purely up to you how you want to write your expression. So let's do that sort of question. Let's find the equation of the curve. We're told that it passes through the point 1, 1, so we have some extra information. It has a gradient function. A gradient function. What on earth is a gradient function? Well, that's just a fancy way of saying the derivative. Because remember, the derivative measures the gradient or the slope. So gradient function, they're basically telling me that the derivative is 2x plus 3. Because it's an equation of a curve we're finding, I'm going to call it dy dx instead of f dash x. So dy dx is 2x plus 3. So y must be, add 1 to the power, we get 2 over 2, but the 2 cancels with the 2. So we've got x squared, the 3 becomes 3x plus a constant. But now I can use that extra piece of information they gave me. I know it passes through the point 1, 1. So if when x equals 1, y equals 1, I can substitute that in and actually work out what that constant was. And in this case, it's negative 3. So we get x squared plus 3x minus 3. All right, that'll do us for this year, yes.